This poster entitled, Development of Online Support Tools for Creating STEM Educational Materials is presented by Tetsuo Fukui, Mukogawa Women's University, and Shizuka Shirai, Osaka University from Japan. Video-based learning, VBL, has gained popularity among students because they can repeatedly take video lectures at their own pace anywhere, anytime, and many times. While, despite these benefits, there are challenges that are preparing the lecture videos burdens teachers as time-consuming and overburdened work. Especially, lecture videos include equations. There will be other problems with mathematical expressions that cannot be used as well as natural language. The left figure is an example of a lecture slide for STEM education. To prepare lecture video from the slide using TTS system, teachers have to create the material through 3 steps, namely, Step 1: create a graph, Step 2, create a slide, and Step 3, create a video. A support framework was introduced for STEM educational materials. The framework consisted of 2 types of tools, namely a graph maker and a text generator for TTS systems. The following figure displays the proposed framework of online support tools for creating lecture videos. The proposed framework, MathTouch Cloud, provides various tools for creating educational materials, including mathematical expressions. The MathTouch input interface of this framework in the crux of the framework. MathTouch is an online WYSIWYG equation input editor developed in JavaScript and enables users to input a mathematical expression by inputting colloquial-style linear strings and selecting the desired equation from the conversion list. The notable feature of MathTouch is that complex formulas need not be entered by using the method that allows users to select candidates based on predictive conversion with AI from ambiguous formula keywords. For instance, equation y equals 1/3 x squared is presented as the first candidate, second row, from the keyword y equals 1/3/2 in the text area as displayed in MathTouch. The text of such ambiguous formula keywords is called colloquial-style linear string. Users can enter the desired mathematical expressions in 3 steps. Step 1 is to input a colloquial-style linear string corresponding to the desired mathematical expression from the keyboard. Step 2 is to select the correct string from the candidate list presented by predictive conversion. And finally, Step 3 is to use the output in the desired format, such as LaTeX, MathML, PNG, JPEG, EPS, Maxima, Maple, and Mathematica, for any desired teaching material. Colloquial-style linear strings do not require entering invisible power signs and parentheses as a delimiter. For instance, limit is represented by lim, and arrows greater than infinity is represented by the initial letter I, and 1/2 to the nth power is represented by 1 to n. The Graph Maker enables users to create the desired graph interactively online. This tool allows teachers to download an image file, PNG, for their slides or documents. First, users insert a math script for the desired graph drawing from the palette of math elements to begin a graph creation. Next, the graph elements, such as the function curve, point, vector, or equation label, are displayed on the canvas by editing the corresponding equation on the script lines using MathTouch. Finally, the graph creation is completed by adjusting the options for each selected element. Press the Append button, then the palette of math shapes will appear. Selecting equation graph from there will bring up the initial graph on the canvas and add to shape script in the graph list. The desired function curve will be displayed on the canvas by editing the corresponding equation on the script lines using MathTouch. In this time, I input y equals x squared. Selecting a shape on the canvas or the corresponding line number in the graph list, arrows user to adjust the options for the shape, e.g., XY domain, line color or width. Next, append a point by selecting point and pointing anywhere on the canvas. and revise the coordinate to square root 2, then the 8-point move just on the function curve, and set its supplemental line. In terms of the AI-based formula input UI, math touch, numerical values such as coordinates can be expressed in formulas such as square root 2. Therefore, this method differs considerably from approximate drawing tools by using the mouse. Next, append the equation label by copying the corresponding equations from the previous function curve line and pasting the label line, and move to a suitable position. Similarly, the point coordinate label is arranged nearby the corresponding point. It is important that equation or coordinate labels can be displayed clearly on the canvas. Finally, output the fixed graph. Text generator enable users to create the speech text for TTS systems from latex source including mathematical expressions. Furthermore, the generator allows teachers to create lecture videos using synthetic speech data from the previous speech text. This tool consists of the latex source input unit on the upper left side, the speech text output unit on the lower left side, and the reading check area on the right side. First, teachers are required to copy the script written in a LaTeX format and paste it into the LaTeX source area. Next, when teachers press the conversion button, the LaTeX source, including mathematical expressions, are converted to a speech text and output the speech text into the speech text output area. The mathematical document is displayed as an actual textbook in the reading check area. This display allows teachers to check the generated speech text by the Google Text-to-Speech API. Y equals 1/3 x squared. We focused on developing a text generator to read approximately 4,000 equations included in the Japanese high school textbooks. For instance, a question and solution document on calculus in LaTeX form is pasted into the source area and push the conversion button, then the corresponding speech text is output in the below. Actually, you can check the highlight line in the math document by this read the line button. Therefore, the speech script on the speech text output unit is available for TTS systems to create voice synthesis data. Question 2. Differentiate x squared plus 1 to the 4th power. Solution. Let y equals x squared plus 1 and z equals y to the 4th power, then dy dx equals twice x and dz dy equals 4y cubed. Therefore dz dx equals twice x times 4y cubed equals 8x squared plus 1 cubed. This study proposed a novel online support framework for creating STEM educational materials that focus on easing the of denoting mathematical expressions in TTS applications. We plan to use feedback and comments from users to improve features of the tool. Please find the 2 tool links below or in our PDF poster. Thank you.